Hey, this is the video for page 5 of trig equations and identities. Just to review the last problem we did on page 4, this one here. Just wanted to go over the steps. Now that we're going to be doing more complex problems, just wanted to overview the steps of the process because the steps are usually the same. First thing we did is we isolated cosine. Now in this case, cosine is already isolated, but sometimes you need to isolate it. So next thing, it talks about the table headers. So we form the table. In this case, there's 3 columns. There's the original x. There is the transformed x. Sometimes you're going to need more than one column depending on how many steps. In this case, there was just one transformation step, which was to add pi over 3, so just one additional column. And then finally, one last column to take the cosine of each one of the angles in the second column. Okay, so we put the table headers there. Next, what we're going to do is we're going to find the boundaries here. Okay, so for example, the domain boundaries they give are 0 to 3 pi. So we put 0 and 3 pi here in the first column. After we put the original 2 boundaries here, we transform them by doing this transformation. We add pi over 3 to both. And that generates the new boundaries for the transformed domain. And these new transformed domain boundaries are useful for figuring out when we stop adding and subtracting 360 degrees. Okay. Fourth step, we find the 2 principal solutions, the solutions that we have memorized between 0 and 2 pi. In this case, it was pi over 3 and 5/3 pi. Those are the ones we have memorized for our sine, cosine, tangent quizzes. And then we add and subtract 360 to generate other solutions. So we add 360 to the 2 original solutions to get others. We subtract, and we do that until we run into the boundaries. When we run into the boundaries, we stop. Okay. Last of all, we find the original x values for all of our transformed values. So first we populate this column here. Then we go backwards and we, not that one. We go backwards and we find the x domain solution. So we subtract pi over 3. We do the opposite of this process. Okay? So that's what we're going to do. We're going to do those 6 steps for each one. Sometimes we don't need to do all the steps, but in a complete problem, we would do those 6 steps. All right? So let's do number 6 now. All right, so number 6. First thing we're going to do is we're going to isolate cosine. You can see that we do need to isolate cosine in this case because it's multiplied by 4 and added 2 to it. So we are going to do a little bit of algebra. First thing we're going to do is we're going to subtract 2 from both sides. So we get 4 cosine 3x equals -2. Then we're going to divide 4 from both sides, and then we would get cosine 3x equals -2 over 4, which is equal to -1/2. Now we're all ready to do the next step, which is to put the table headers on. So basically we have our first column being just regular old x, and then the second column we're going to put our transformed x value. And then finally we're going to put the cosine of 3x as our third column. Okay, now let's move on to number 4. We're going to find the 0 to, oh, I forgot, number 3. We're going to put the domain boundaries in the table. So I'm going to do that in gray, and I'm going to put -pi to pi first as my x domain boundaries. And then I'm going to multiply each one of these by 3 because the transformed domain would be 3 times that. So -3 pi and +3 pi, okay, are my adjusted boundaries. Okay, now we're going to do number 4. We're going to find the solutions between 0 and 360 degrees in the transformed x domain. So we're going to look at our isolated cosine. The isolated cosine says the cosine of 3x equals -1/2. So what we want 2 solutions that have cosines of -1/2. What 3x value would give us a cosine of -1/2? Remember cosine -1/2? That would be these tall triangles, these 2 tall triangles here, right? So what are the solutions between 0 and 360 degrees? So this one here is 120, and this one here is, I think, 240. So 120 degrees in radians is 2/3 pi. And then the other one is 4/3 pi. Okay, so I put down my two 3x domain answers, and those are the two memorized values between 0 and 3 pi. Okay, next step, we are going to add and subtract 360 to those proposed solutions until we go past our boundaries 3 pi and negative 3 pi. Okay, so let's subtract 3 pi first from this angle and this angle. If we subtract 2 pi from 4/3 pi, we're going to subtract 6/3 pi, right? That would be negative 2/3 pi. And if we do that for 2/3 pi, that would be negative 4/3 pi. Okay, and it looks like we might need more space. Okay, let's see. So now let's try one more time. We're going to subtract another 6/3 pi from here, and that would give us negative 8/3 pi. And then this one would be negative 10/3 pi. We're getting close to negative 3 pi, right? Because negative 3 pi would be negative 9/3 pi. Negative 9/3 pi. And we just went past it. So negative 10/3 pi is actually less than negative 3 pi, so we reject that one. Negative 8/3 pi is still okay. Okay? All right, now we're going to add 6/3 pi to each one of these. So if we add 6/3 pi to 2/3 pi, then it would be 8/3 pi. And then if we add 6/3 pi to 4/3 pi, that would be 10/3 pi. And 10/3 pi, of course, is bigger than 3 pi because 3 pi is 9/3 pi, so this is also too far. Okay, so we now have all of our intermediate solutions, negative 8/3, negative 4/3, negative 2/3, positive 2/3, positive 4/3, and positive 8/3 pi are all of our intermediate solutions. And the last step is we are going to reverse the transformations to find the x solutions. So now what we do is we just undo each of these. Okay, so how do we undo it? We divide by 3. Instead of multiplying by 3, we divide by 3. So negative 8/3 pi becomes negative 8/9 pi. Negative 4/3 pi becomes negative 4/9 pi. Negative 2/3 pi becomes negative 2/9 pi. 2/3 becomes 2/9 pi. 4/3 pi becomes 4/9 pi. 8/3 pi becomes 8/9 pi. And all of those solutions are, of course, within our domain of negative pi to pi. And that's because we were carefully monitoring the values in the intermediate result. And when we got too far, when we went past negative 3 pi or 3 pi, we stopped. And that's why we know that the solutions are just these angles here. Okay? All right, so let's move on to the next problem. First thing we're going to do is, okay, so in this case it says, oh, find the exact solution of tangent of x equals square root of 3. Of course, that would be the tall triangles here and here. They said all the ones between 0 and 2 pi, so that would be pi over 3 and 4/3 pi. Those are the two that have positive square root of 3 as a solution. Okay? All right, now let's move on. We're going to do this one here. The first thing is we're going to isolate tangent, but tangent is already isolated, right? Everything's on the right side. Tangent is not multiplied or added to anything, so that's fine. Now we're going to make the table headers. So the table headers, the first column, of course, is going to be x. The second column is going to be the transformed x, which is inside, x minus pi over 6. And then, of course, the last column, we can reserve that for taking the tangent of x minus pi over 6. Okay, so next step, we're going to find the transformed boundaries. So the boundaries are 0 and 2 pi in the domain of x, so we put 0 here at the top, and we put 2 pi here at the bottom. Okay, and then we're going to let's see, we're going to find out the 0 to 360 solutions in the transformed x. So we already did that, actually. We did it right here. They asked us to do that first. So we already have our values. One thing I forgot to do is I forgot to find the transformed boundaries, okay? So 0 transforms to negative pi over 6, and then 2 pi, which is equivalent to 12/6 pi, is transformed to 11/6 pi. So 12/6 pi becomes 11/6 pi, okay? All right, now let's put our two solutions here in the middle here. Pi over 3 and 4/3 pi are solutions for tangent that result, or tangent of x minus pi over 6. These are the intermediate arguments, which would give us a tangent of square root of 3. Okay, so those are the two main solutions. Now let's find other solutions by adding and subtracting pi over 2 pi. Remember 2 pi with 6 in the denominator would be 12/6 pi. So we're going to add 12/6 pi to each one of these. And then we're going to see if we go past the domain that we have. And so if we add 12/6 pi to pi over 3, remember pi over 3 is 2/6 pi. So 2/6 pi plus 12/6 pi is 14/6 pi. 14/6 pi. And I'm just going to leave the thing unreduced for now because it makes it easier to compare it to the domain. And you can see that I already went past. 14/6 is bigger than 11/6, so I stop here. Okay, so by the way, 4/3 pi is 8/6 pi, right? Okay, 2/6 pi and 8/6 pi. Now what we're going to do is we're going to subtract 360 from each one. So let's do that. Okay, so we're going to subtract 360 from 8/6 pi. So we're going to do 8/6 pi minus 12/6 pi. So that would be negative 4/6 pi. And then if we subtract from here, 2/6 pi minus 12/6 pi would be negative 10/6 pi. And you can see that in this case too, we have gone past our domain boundary of negative pi over 6 in both cases. So we can't. So that leaves us with only these two solutions. Okay, so we have 2/6 pi, and to go back to the x domain from this domain, we need to do the opposite of minus pi over 6. We need to add pi over 6. So what we're going to do is we're going to take 2/6 pi and we're going to add pi over 6, and that would be 3/6 pi. And then 8/6 pi, we're going to add pi over 6, and that would be 9/6 pi. So those would be the two valid solutions. You can see that both of these solutions are in between 0 and 2 pi, so they're both fine. Of course, 3/6 pi, we can reduce that to pi over 2. And 9/6 pi, of course, we can reduce that to 3/2 pi. Okay, just to do the reverse of what we did, just to show you how that goes, if I have 3/6 pi, I can first subtract pi over 6, and that would give me 2/6 pi. And if I took the tangent of 2/6 pi, which is pi over 3, that would give me square root of 3. So I have confirmed my solution. Here, if I have 9/6 pi and I subtract minus pi over 6, I end up with 8/6 pi. And then the tangent of 8/6 pi is 4/3 pi, it's going to be square root of 3. So we've confirmed that those two solutions actually work. Okay? All right, so our solutions in this case in reduced form would be these two. All right, that was page 5. Let's go to page 6. Page 6 just has one giant problem, okay? It is a little bit more complicated because you can see it actually has two transformations. The first transformation is we subtract pi over 4, and the second transformation is we multiply that times 4. Now, do we need to isolate sine? No, because it's already isolated. Sine is already by itself on the left. Okay, then we're going to make our table and we're going to put our headers. Remember, the first header is always x, and then the next header is the transformation. But since the transformation is in 2 steps, we're going to separate it into 2 steps in our table also. So the first column is going to be subtracting pi over 4. And then the third column is going to be, we're going to multiply that transformation times 4. Okay, and then finally, the last column is going to be the sign of everything, 4x minus pi over 4. And of course, we're looking for the result to be 0. All right, the next step is we're going to do the table headers. We already did the table headers. Okay, so next step is we're going to do the domain boundaries. So the domain boundaries are 0 and pi. And so those are, of course, the domain boundaries for x. So we're going to put 0 and pi in the x column, okay? And then we're going to, maybe I should put the pi down here. I don't know exactly how many solutions there are. Okay, and then we're going to change our domain boundaries using these two transformations. So the first transformation is we subtract pi over 4. The second transformation is we multiply that by 4. So then 4 times negative pi over 4 is just negative pi. Okay, so that would be one of the boundaries, the initial boundary. And at the bottom, I'm going to subtract pi over 4. So that would be 4/4 pi minus 1/4 pi would be 3/4 pi. And then I'm going to multiply that by 4. And so that would be 3 pi. Okay. So now we have this column here, right before we get to sign of 4 whatever. We're going to write down our two main solutions here, okay? So we've done this. Now we're going to find the 0 to 360 solutions in the transformed x column. So one of those solutions, let me change color to red. So what angles have a sine of 0? Oh, so that would be 0 degrees, right? And also 180 degrees, or pi. And then don't forget 2 pi. Oh, yeah, and don't forget 2 pi. So let's put also 2 pi. So there's actually 3 solutions. 0, pi, and 2 pi have a sine of 0. So I'm going to write all those down. 0, pi, and 2 pi. So usually we have like 2 solutions, but it's possible just to have 1 solution. It's possible to have 3 solutions in this case, okay? So those are the 3 possible solutions. Next, I'm going to add and subtract 360 to find more solutions. So let's see. And now what I'm doing is I'm going to add and subtract 360, which is adding and subtracting 2 pi, until we get to 3 pi. So if I add 2 pi to 0, of course, it's 2 pi. Oh, we already have that solution. Okay. And then if we add 2 pi to pi, we get 3 pi. Oh, and we've already arrived at the boundary. So then we stop, right? We can also go backwards. We're going to subtract pi. So if we subtract pi from 2 pi, we just get pi. We already have that solution. I'm sorry, if we subtract 2 pi from 2 pi, we get 0. We already have that solution. If we subtract 2 pi from pi, we get negative pi. And then we're already at the boundary, so then we stop there. So actually, we didn't need as much space as I thought, right? We just have 1, 2, 3, maybe 5 possible solutions, okay? We are stopped by the 3 pi here. We are stopped by the negative pi up top, all right? All right, now what we're going to do is we're going to reverse the transformations to find the x solutions. Okay, so we know that all of these intermediate arguments result in a sine of 0, right? If I do sine of negative pi, it's 0. If I do sine of 0, it's 0, etc. All these result in 0. So now what we're going to do is we're going to go backwards. We're going to do these transformations backwards. So negative pi, the reverse transformation here is to divide by 4 instead of multiplying by 4. So I'm going to divide negative pi by 4, and then it will give you negative pi over 4. What do you know? It matches. Of course it matches, because this also matches. Dividing 0 by 4 is still 0. Dividing pi by 4 is pi over 4. Dividing 2 pi by 4 is 2 pi divided by 4. You can also write pi over 2. And 3 pi divided by 4, of course, is 3 pi over 4. And of course, that one matches this because it's on the boundary, okay? Last of all, we're going to go back to the x domain here. When we go back to the x domain, we need to do the reverse of this. And this is subtracting pi over 4. So we're going to add pi over 4 each time. So if we add pi over 4 to negative pi over 4, we get 0. Of course, it matches this because it's at the boundary. If we add pi over 4 to 0, we get pi over 4. If we add pi over 4 to pi over 4, we get 2 pi over 4, also known as pi over 2. Okay? And then if we add pi over 4 to 2/4 pi, we get 3/4 pi. And finally, if we add pi over 4 to 3/4 pi, we get 4/4 pi, also known as pi. And of course, that matches the boundary because we knew we were at the boundary. Now I'm just going to highlight all the answers. So this is a possible answer, this is a possible answer, this is, and this is. So there are 1, 2, 3, 4, 5 solutions. All right, so that was page 6. If you want to check to make sure that the answers are correct, these yellow answers are correct, all you need to do is put them through this process, okay? I'm going to do it here just by looking at the original expression, show how this works. Now, this is not using the table. It's like, what if you were not using the table? I would say, okay, what if I put 0 in here? If I put 0 in here, 0 minus pi over 4 is negative pi over 4. Negative pi over 4 times 4 is negative pi. So basically, I would have sine of negative pi, and of course, sine of negative pi is negative 180 degrees. The sine of negative 180 degrees is 0. And then so, oh, okay, so it worked, all right? So 0 is indeed one of the solutions. You could repeat that for all the others. Now, it's a little bit easier to break it down in the table, so that's why I use the table, all right? I can do very complex problems in the table, and then the complexity of the problem is not any more complex than an easy problem. It's just that you have to repeat it more times, but the steps are not algebraically difficult because everything is laid out like this. All right, that's it.